So far guys, we have discussed addition of vector. Now the another operation is multiplication of two vectors. Okay, how do we multiply vector actually? So in that series there are two type of vector multiplication. One is scalar product, one is vector product. Scalar product and another is vector product. So as the name suggests, scalar product gives you scalar resultant would be scalar, and the vector product gives you the resultant, which is a vector. So we also call a scalar product as dot product and the vector product as cross product. Okay, so let's proceed with the scalar. So scalar product or dot product, I'll refer it as a dot product. Okay, dot product or scalar product between two vectors. It comes into role when the resultant has to be a scalar, not a vector. So scalar product is defined as, say, the product of two vectors a dot b is C. So that C is, A is a vector, B is a vector, of course, with the arrow you can see that C is not having arrow, this is a scalar. So other way of defining this as is A vector magnitude, B vector magnitude, cos theta, cosine of the angle between them. So this is the scalar product. This is how we define a scalar product. And examples are like in case of work is the scalar product of force and the displacement in the direction of force. Okay, force and the displacement. So Fs cos theta. So work is a scalar, but force and displacement both are the vectors. Okay, so this is how is the scalar product or the dot product. Then if I give you one vector, and there is one more important thing with that, I shall discuss it with you, which is important. Say for example, I write there are two vectors, vector A and vector B, and the angle between them is theta. So I can write A dot B as A vector B magnitude and cos theta. So here if I say what is B cos theta, B cos theta is actually represent the projection of B over A. B cos theta is this na, so projection of B over A. So projection of B over A of over A, which would be projection of B over A. So which would be it would be A dot B vector, dot product of them, over magnitude of A vector. So the thing is, this is one application of dot product to finding the projection of one vector over other. Okay, so there are multiple, this is not a difficult thing, dot product, cross product. So I'll ask you some question. Say for example, if I say what is the dot product of I cap, what is I cap? They are actually unit vectors in the direction of representing positive x-axis. Say for example, if I say dot product of a vector, A vector and A vector, so it would be like both are the same vector, so it would be magnitude of A and cos 0. And what is cos 0? 1. Cos 0 is 1, cos 180 is negative 1, so it would be just the magnitude of A square. So if I say the dot product of I cap, it would be I cap magnitude square, that is 1. So what is the dot product of j cap dot j cap? Again 1. What is the magnitude of k cap dot k cap? Both are unit vectors, and the magnitude of k cap square, that is again 1. And if I ask you what is the magnitude of I cap dot j cap, in this case it would be 0. because the angle between I cap, x-axis and y-axis is 90. So here it would be na, say for example I cap j cap magnitude cos 90, and cos 90 is 0, so that's why it would be 0. So if any other, like the j cap dot k cap, it would also be 0. I cap dot k cap, it would be also be 0. Okay, so these represent the various dot products. And if I say for example, easy questions, easy problem, there is a vector a having magnitude like 5, and there is another vector b having magnitude as 6, and angle between them is 60 degree. So what is the dot product? A dot b, nothing but 5 into 6, the cos 60 is half, so that would be 15. Okay, and do I need any direction sense? No, because the dot product is itself a scalar, so it would be a scalar only. So just the magnitude, I just need to bother about the magnitude, not this arrow. Okay, so only 15 is okay. Say for example, this is a Newton, 6 Newton, 5 Newton, so it would be just 15 Newton, only unit, no direction are we required. Then you would ask, what would be the dot product if the vectors are represented in Cartesian form? Don't bother about the Cartesian. Cartesian is nothing but just the I cap, j cap, that is. So for example, I write this thing, a vector is this, and b vector is, take for example this also, k cap also. B vector is I cap minus 4j cap plus k cap. So what would be a vector dot b vector? So in that case, this is actually Cartesian form. Okay, I cap, j cap, k cap form. So it would be, I'm writing this, so you just need to multiply. If this is a dot product, the I cap with I cap, j cap with j cap, k cap with k cap. Actually you're multiplying every variable with every variable, but the thing is, with I, when you're multiplying I cap with the j cap, the answer is 0, so you don't need to bother about that. When you're multiplying I cap with k cap, it is 0. So the only thing you need to bother about, I cap and I cap, j cap and j cap, so the number preceding those. So 2 into 1 is 2 plus 3, multiply minus 4 is minus 12, minus 5, 1 is minus 5, so it would be 17 to 15. Negative 15 would be the amplitude, oh not amplitude, magnitude. Okay, this is how you do the dot product in Cartesian form. Okay, so let's talk another type of the vector product, which is a scalar product. Vector product. Scalar product we had discussed. Vector product or cross product. Okay, it happens, cross product. So cross product, in case of the cross product, if I say C is the cross product of A vector and B, so C has to be a vector. Vector product, by the name suggests, the resultant is a vector. Like in case of the torque is a position vector, displacement and force, for that matter just take it as a displacement and force. So this is the actually that is the displacement. I'll tell you how is the displacement is the position vector and the force. Okay, so where the force is applying. So torque is a vector and is a cross product of two vectors. What does a cross product actually means? So if the resultant is a vector, then we should also be bothered about the direction. So cross product is defined as, if I say C, it is A vector, magnitude of A vector, magnitude of B vector, sine theta angle between them, and this n cap. N cap represent the direction of the resultant vector, which is, say for example, I'll tell you, say for example this a vector, vector A, this is vector B, the angle between them is theta. So their direction would be represented by this is n cap. In fact, if their plane is this, vector A and vector B plane is this, so the resultant of their vector, which is C, which is n cap, which is represented by n cap, it would be perpendicular to both. So cross product is always perpendicular to both. Okay, so if I say vector A equivalent to 5 and vector B, magnitude of course, is equivalent to 6 and theta between them is 30 degree, then find A cross B. So what do you need to do? Nothing but resultant vector, which is this A, B, and sine 30, which is half. So half, take a half, 15, again the 15 comes, and 15 Newton. But in this case you also need a direction as well. So I represent with the n cap. N cap is nothing, just perpendicular to both vectors A and B. So it's perpendicular to the plane. It can be inside and outside as well. They were A and B na. So this was their plane. So the resultant of A and B would be like, this is the direction of their resultant n cap, either this or either this, either upwards or downwards, inside or outside the plane. Okay, so this is how does the vector products work, and there are ample example of that, how do we actually find the direction. But first of all, let's talk about the different vectors. Say for example, if I say I cap cross I cap, if I say there is a vector cross that vector, I cap is a unit vector for representing x-axis, so in that case it would be vector A square sine theta. And what is the angle between two vectors? Same vector, 0. So this would be 0 only. Okay, it would be maximum when angle is 90, it would be 0 when angle would be zeros, opposite to the cross dot product. Cross product is opposite. Okay, so I cap would be 0. I cap j cap would be, magnitude would be 1, and now here is plus minus is different. Okay, plus 1, j cap cross k cap. I'll tell you how to find the direction. J cap cross k cap, it would be I cap. Okay, k cap cross j cap, it would be j cap. But if I say j cap cross j cap, it would be 0. K cap cross k cap, because the angle between these two 0, so sine 0 is 0. But you might be wondering how I'm writing this and this. Okay, just for I need to write k cap here. Okay, magnitude is 1 k cap, but direction is k cap. Magnitude here is also 1, but direction is I cap. Here is j cap. But you know one thing, if I write k cap cross j cap, it would be negative of I cap. Then you must be thinking, how could we came to know what would be the answer, and how is sometimes it is coming as plus I cap and sometimes coming as negative I cap. Okay, so for that I'll give you a rule.